Hello student, today we will discuss the another topic in this chapter, units and measurement. In the last class you have studied the physical quantity and types of physical quantity. Today we will see the dimensional analysis. So before that we will see the what is dimension. Dimension and then actually dimensions are the power to which the fundamental physical quantities are raised in order to represent derived physical quantity. We know derived physical quantity is derived from fundamental quantity. That means derived quantity is the product of the fundamental quantity. That means we are going to derive the derived physical quantity in terms of fundamental physical quantity. So dimensions are the powers to which the powers to which, or we can write like this, the dimension of a physical quantity are the powers ಏನಿದು powers to which the fundamental physical quantities are raised in order to represent that physical quantity. See, power rises to a fundamental physical quantity. Okay, for example, take a velocity. Velocity definition is rate of change of displacement. We are going to study these things in next chapter, that is motion in a straight line. So velocity is what? Length by time. Okay, length means length under L. So T. So dimension of this is, so we can write dimension of velocity is m power 0 L t power minus 1. Dimension of L in a velocity is 1. Dimension of t in a velocity is minus 1. Dimension of m is 0. So the powers are 0. So this is the dimension. ಹೀಗೆ ನಾವು ಡೈಮೆನ್ಷನ್ನ ಡಿಪೆಂಡ್ ಮಾಡ್ತೀವಿ. ಇಟ್ ಆ್ಯಕ್ಚುಲಿ ಪವರ್ಸ್ ಟು ವಿಚ್ ದ ಫಂಡಮೆಂಟಲ್ ಕ್ವಾಂಟಿಟೀಸ್ ಆರ್ ರೈಸ್. We'll see the dimension of some other physical quantities. We see the dimension of some other physical quantities. Velocity is L t power minus 1. The basic physical quantities. Area is what? Length into length. So it is meter square. Its unit, SI unit, meter square. This is length square. So area, dimension of area is length square. Volume, length into length. So L cube or meter cubes. This is L cube. Volume, this is L cube. So velocity ಗೊತ್ತಿದೆ, L t power minus 1. So next, acceleration. A. What? Velocity, rate of change of velocity ಅಂತ ಬರುತ್ತೆ. So velocity by time. Velocity dimension is actually L t power minus 1. This is t. So L t power minus 2. So dimension of acceleration is L t power minus 2. So next, force. This mass into acceleration. Mass is m. So dimension of force is m. Acceleration L t power minus 2. Next, momentum. Momentum andre mass into velocity. Mass into velocity. Momentum, this is linear momentum, okay? Linear momentum P. Mass velocity L t power minus 1. This is the dimension. Here force, the SI unit of force is what? Newton. So derived unit is what? Mass, kg. Acceleration, meter per second square. Okay, acceleration unit is meter per second square unit. So this is Newton is the SI unit. Kg, meter per second square, is the derived unit. Next, pressure. Pressure is what? Force per unit area. We know the dimension of force, ml t power minus 1, ml t power minus 2. So area, L square. So pressure, dimension of pressure is m L power minus 1 t power minus 2. Next, density. Density is what? Mass by volume. These are the formulas I think you have studied in the intermediate ಅಲ್ಲಿ ಕಲ್ತಿರ್ತೀರಾ. So mass by volume. Mass dimension, mass symbol m, volume L cube. So dimension of rho, density is what? M L power minus 3. Next, force, density, work or energy. This is force into displacement. Okay, this is actually a dot product. Okay, so what we can write? F dl cos theta. You know, dimension of unit of theta is degree or radian, but it is dimensionless physical quantity. Theta, plane angle and solid angle, both are dimensionless physical quantity. So force, so it will become a number, alva? Cos theta. Theta is also dimensionless. Cos theta is just a number. So dimension of force is what? ml L t power minus 2 dl, length L. So the dimension of energy or work is m L square t power minus 2. So dimension. There are different quantities are there which are dimensionless physical quantity. For example, refractive index. ಅದಕ್ಕೂ ಮೊದಲೇ ಇಲ್ಲಿ ಒಂದು ನೋಡೋಣ. ಆ್ಯಕ್ಚುಲಿ ದಿಸ್ ಇಸ್ ದ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಯೂನಿಟ್, SI unit of work is what? Joule. But its derived unit is what? Force, kg, meter square. The derived unit. Okay. Dimensionless physical quantities are there. For example, the refractive index. Refractive index. ಇದನ್ನು ನೆಕ್ಸ್ಟ್ ರೇ ಟಾಪಿಕ್ಸಲ್ಲಿ ಆಪ್ಟಿಕ್ಸ್ ಅಲ್ಲಿ ಕಲಿತೀವಿ ಆ್ಯಕ್ಚುಲಿ. ಸೊ ವಾಟ್? C/P, velocity of light in a vacuum by velocity of light in medium. So ಇದರ ಆ್ಯಕ್ಚುಲಿ ಡೈಮೆನ್ಷನ್ ಏನು? L⁻⁻1 L⁻⁻1 ಇದು ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಸೊ ಇಟ್ ಈಸ್ dimensionless physical quantity. There are many dimensionless physical quantities are there. So I think you have to go through the book. Okay. These are the some of the physical quantities and its dimensional formula. Next we will see dimensional analysis and its application. Dimensional analysis and its application. ಓಕೆ, ಡೈಮೆನ್ಷನ್ ಏನು ಅಂತ ಗೊತ್ತಾಯಿತು. ಈಗೇನು ಡೈಮೆನ್ಷನಲ್ ಅನಾಲಿಸಿಸ್ ಮಾಡೋಣ. ಸೊ ಇದರಲ್ಲಿ ಒಂದು ಬರುತ್ತೆ, ಪ್ರಿನ್ಸಿಪಲ್ ಆಫ್ ಹೋಮೋಜಿನಿಟಿ ಆಫ್ ಡೈಮೆನ್ಷನ್. ಪ್ರಿನ್ಸಿಪಲ್ ಆಫ್ ಹೋಮೋಜಿನಿಟಿ ಆಫ್ ಡೈಮೆನ್ಷನ್. ಹೋಮೋಜಿನಿಟಿ ಆಫ್ ಡೈಮೆನ್ಷನ್. Homogeneity of dimension is, homo means what? Same. Another ಏನು ಹೇಳುತ್ತೆ this principle? What it says? Okay, that it says the physical quantities which have the same dimension can be added or subtracted from one another. ಯಾವುದು ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸ್ದು ಸೇಮ್ ಡೈಮೆನ್ಷನ್ ಇರುತ್ತೋ ಅಂಥ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸ್ ಅಷ್ಟೇ ನಾವು ಆ್ಯಡ್ ಮಾಡ್ಬೋದು ಅಥವಾ ಡಿಫ್ರೆನ್ಸ್ ಮಾಡ್ಬೋದು. ದಿಸ್ ಇಸ್ ದ ಪ್ರಿನ್ಸಿಪಲ್ ಆಫ್ ಹೋಮೋಜಿನಿಟಿ ಆಫ್ ಡೈಮೆನ್ಷನ್. ಅಂದರೆ ಆ್ಯಕ್ಚುಲಿ ಏನಿದ್ರ ಅರ್ಥ? ವಿ ಕ್ಯಾನಾಟ್ ಆ್ಯಡ್ ಫೋರ್ಸ್ ಟು ಅ ವೆಲಾಸಿಟಿ ಆರ್ ಎನರ್ಜಿ ಟು ಅ ಫೋರ್ಸ್. ದೆನ್ ಡಿಫ್ರೆಂಟ್ ಡೈಮೆನ್ಷನ್ ಇದ್ದ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸನ್ನು ಆ್ಯಡ್ ಮಾಡಲಿಕ್ಕೆ ಆಗಲ್ಲ. ಸೊ ಇದರಿಂದ ಏನೇ ಯೂಸ್ ಆ್ಯಕ್ಚುಲಿ ಹೋಮೋಜಿನಿಟಿ ಆಫ್ ಡೈಮೆನ್ಷನಿಂದ ವಿ ಕ್ಯಾನ್ ಚೆಕ್ ದ ಕರೆಕ್ಟ್ನೆಸ್ ಆಫ್ ಇಕ್ವೇಷನ್. ಈಗ ಯಾವುದೋ ಒಂದು ಇಕ್ವೇಷನ್ ಇರುತ್ತೆ, ನಾವು ಆ ಇಕ್ವೇಷನ್ ಕರೆಕ್ಟ್ ಇದೆಯಾ ಅಂತ ನೋಡಲಿಕ್ಕೆ ಏನು ಚೆಕ್ ಮಾಡ್ಬೋದು? ಡೈಮೆನ್ಷನ್ ಚೆಕ್ ಮಾಡ್ಬೋದು. ಎವ್ರಿ ಟರ್ಮ್ ಡೈಮೆನ್ಷನ್ ಚೆಕ್ ಮಾಡ್ಬೋದು. ಸೊ ಇಫ್ ದೇ ಆರ್ ಡೈಮೆನ್ಷನಲಿ ಸೇಮ್, then we can say the equation is dimensionally correct. We'll take one example. This is one equation. X is equal to x naught plus vt plus 8t square. This is one equation. The homogeneity of dimension, the principle of homogeneity of dimension in here actually the physical quantities which are same dimension can be added or subtracted. Okay, ಯಾವುದು ಸೇಮ್ ಡೈಮೆನ್ಷನ್ ಇರುತ್ತೋ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸನ್ನು ಅದನ್ನು ಆ್ಯಡ್ ಮಾಡ್ಬೋದು ಅಥವಾ ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ಬೋದು. ಸೊ ಲೆಟ್ಸ್ ಚೆಕ್. ಡೈಮೆನ್ಷನ್ ಆಫ್ ಎಕ್ಸ್ ಇಸ್ ವಾಟ್? x naught are length, v is velocity, a is acceleration. This is L. This is x naught. So this is also length. So vt. Dimension of velocity is what? L t⁻⁻1 t. This is dimension L. Dimension of at square. Dimension of acceleration is what? L t⁻⁻2 t square. This is L. So LHS is equal to RHS. So this equation is dimensionally correct. But ಇದು dimension method ಇಂದ ಏನು ಪ್ರಾಬ್ಲಮ್ ಅಂದರೆ ಆ್ಯಕ್ಚುಲಿ dimensionally correct equation cannot be correct in physical way. Physical equation ಆಗಿ ಕರೆಕ್ಟ್ ಆಗಿರ್ಬೇಕಂತ ಏನಿಲ್ಲ. ಬಟ್ dimensionally incorrect equation is wrong. But dimensionally correct equation is not necessarily to be a physically correct equation. ಯಾವ physically correct equation ಆಗಿರ್ಬೇಕಂತ ಏನಿಲ್ಲ. Okay. So next we'll take some example. Another example. V is equal to U plus 8. ಇದು ಡೈಮೆನ್ಷನಲಿ ಕರೆಕ್ಟ್ ಇದೆ ಇಕ್ವೇಶನು ಮತ್ತು ಫಿಸಿಕಲಿನೂ ಕರೆಕ್ಟ್ ಇದೆ. ದಿಸ್ ಇಕ್ವೇಶನ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡಿರೈವ್ ಇನ್ ನೆಕ್ಸ್ಟ್ ಚಾಪ್ಟರ್, ಮೋಷನ್ ಇನ್ ಸ್ಟ್ರೇಟ್ ಲೈನ್. ಸೊ ವೆಲಾಸಿಟಿ, ದಿಸ್ ಈಸ್ ಫೈನಲ್ ವೆಲಾಸಿಟಿ and this is initial velocity. A is acceleration, T is time. So dimension of Vt is what? L t power minus 1. U, this is also velocity. L t power minus 1. Acceleration, A minus 2 t. So this is, so ಎಲ್ಲ term dimension same ಇದೆ. So we can be added. Okay. Next we will see the application of dimensional method. What is this application? ಎಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡ್ಬೋದು ಇದನ್ನು? We can apply this dimensional method to deduce the equation. Like we can deduce the relation among the physical quantities. ಓಕೆ, ಯಾವುದಾದ್ರೂ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸ್ ನಡುವೆ ಇರುವ ರಿಲೇಷನನ್ನು ಡಿರೈವ್ ಮಾಡ್ಬೋದು ನಾವು. ಸೊ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಸಿಂಪಲ್ ಪೆಂಡುಲಮ್, ಟೈಮ್ ಪೀರಿಯಡ್ ಆಫ್ ದಿ ಸಿಂಪಲ್ ಪೆಂಡುಲಮ್. ಐ ಥಿಂಕ್ ವಿ ನೋ. ಓಕೆ, ದಿಸ್ ಈಸ್ ಸಿಂಪಲ್ ಪೆಂಡುಲಮ್. This is simple pendulum. Mass, the acceleration due to gravity g, it is oscillating. This is length, it is oscillating. So angle theta. ಇದರ ಟೈಮ್ ಪೀರಿಯಡ್ ಅನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಇದರ ಟೈಮ್ ಪೀರಿಯಡ್ ಅವರ ಅಬ್ಸರ್ವೇಷನ್ ಪ್ರಕಾರ ಏನು, ಟೈಮ್ ಪೀರಿಯಡ್ ಮೇ ಡಿಪೆಂಡ್ ಆನ್ ದ ಮಾಸ್ ಆಫ್ ದಿ ಬಾಬ್ ಆ್ಯಂಡ್ acceleration due to gravity and length of the pendulum. So we'll take, ಬಟ್ ಯಾವ ಡೈಮೆನ್ಷನಲ್ಲಿ ಡಿಪೆಂಡೆನ್ಸಿ ಇದೆ ಅಂತ we can deduce this, the equation for the time period of the simple pendulum. Okay, this is constant L power x and G power y, M power z. L length, G is acceleration due to gravity, M is mass. Okay, we know the dimension of this physical quantity. Dimensional method ಅಂದರೆ actually LHS should be equal to RH. LHS RHS ಗೆ equal ಆಗಿರಬೇಕು. So what is the dimension of T? Time period. Dimension of T is M power 0, L power 0, T power 1. So what is the dimension of the RHS? L power x, G power. And dimension of the acceleration due to gravity. This is y, mass, M, 0. ಇವೆರಡನ್ನು ಈಕ್ವಲ್ ಮಾಡಬೇಕು. So this is equal to M power 0, 1. ಸೊ ಇವಾಗ ಏನು ಮಾಡಬೇಕು, ಪವರ್ಸನ್ನು ಈಕ್ವಲೇಟ್ ಮಾಡಬೇಕು. ಸೊ ಎಲ್ ಪವರ್ ಎಕ್ಸ್, ಎಲ್ ಪವರ್ ವಾಯ್. ಸೊ ಎಕ್ಸ್ ಪ್ಲಸ್ ವಾಯ್. ಹಿಯರ್ ಎಲ್ ಪವರ್ ಈಸ್ 0. ಟಿ ಪವರ್ ಮೈನಸ್ ಟು ವಾಯ್. ಇಲ್ಲಿ ಟಿ ಪವರ್ 1. ಸೊ ಎಮ್ ಪವರ್ ಝೆಡ್, ಝೆಡ್ ಹಿಯರ್ 0. It shows the time period is independent of mass. So after solving this, y is equal to minus 1 by 2. So here x is equal to minus y. So x is equal to half. So what we can write? K L power half G power 1 by 2 minus 1 by 2. So we can deduce the equation. Here is the equation. ಇದರದೇನು disadvantage ಅಂದರೆ it cannot explain or we cannot find the constant of this equation. Constant find out ಮಾಡಲಿಕ್ಕಾಗಲ್ಲ through a dimensional method. So we are known what is that constant 2 phi. So ಮತ್ತೇನು ಇರಬೇಕಂದ್ರೆ actually we have to represent the physical quantity in terms of product of physical quantities ಅಲ್ಲಿ represent ಮಾಡಬಹುದು. And ಈಗ ಲೀನಿಯರ್ ಆಗಿದ್ರೆ ಎಷ್ಟೊಂದು ಟರ್ಮ್ ಬೇಕಾದರೂ ಇರ್ಬೋದು, ಡಿಪೆಂಡೆನ್ಸಿ ಆಫ್ ಮೆನಿ ಟರ್ಮ್ ಆಫ್ ದಿ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ. ಬಟ್ ಪವರ್ ಇದ್ದರೆ ಅಪ್ ಟು 3 ವರೆಗೆ ನಾವು ಈ ಮೆಥಡಿಂದ ಡೆಡ್ಯೂಸ್ ಮಾಡ್ಬೋದು. ದಟ್ ಮೀನ್ಸ್ ರಿಲೇಷನ್ ಅಮಂಗ್ ದಿ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ ವಿ ಕ್ಯಾನ್ ಡೆಡ್ಯೂಸ್ ಫ್ರಮ್ ದಿಸ್ ಮೆಥಡ್. ವಾಟ್ ಈಸ್ dimensional method. Okay, today is enough. This much is enough. Thank you.